So this is your lecture number 4. We are continuing with our linked list functionalities. So we did add in the last clip, and now we are going to do delete. So we just did add at the beginning and delete at the beginning. So in the last one we did add at the beginning and add at the end. Now we'll do delete at the beginning and delete at the end. So deletion at the beginning means you're going to delete the first node. The first node means the node whose address is present in the start pointer. So deletion at the beginning will include updating the start pointer. So what are we supposed to be doing in this case? We have to delete this node, means this goes from your linked list, and now this node becomes your new first node. So straight away what we are going to do, we want to make sure that our start pointer is now pointing to this node instead of this node, which automatically takes this out of the picture of our current linked list. So what we do, we say start is equal to start to next. Start on the left side means we are updating start, and this should happen only when you are doing something with the first node of the linked list. Otherwise, whenever we use the start pointer value to traverse or loop through the list, we always copy it to a temp pointer. Okay, so start to next. In the next field of start has 1000, so 1000 to next is 2000. That is what gets copied into start. So now start has 2000 and it's pointing to this. But you should always do it properly, in the sense that since we are deleting a node which we dynamically allocated in memory, we should free that node and return that back to the memory. So what we do is we copy the value that start had into temp, then we do what we did just now, start is equal to start to next, and then we free temp. So this is a good programming practice. You should always, whenever you delete something from the linked list, you should always return that node back to memory so that it can be reused later on. So this was delete at the beginning. Now we have delete at the end. So now to delete the last node of the linked list, you have to get till the end of the linked list. So we will use that loop which we use to traverse a linked list. So we know the end of the linked list is specified by the next field of the last node, which is null. So we know when we reach the last node. But if we have to delete your, let's say if we have to delete this node 15 here, so you cannot be at 15 and delete 15, in the sense that if you remember the example, when you cut the branch of a tree, you don't sit on the side of the branch which you are cutting. You sit on the inner side and then cut the branch so that it falls off. So we don't sit or we don't point here when we are deleting 15. We should be here. Why we should be here? Because now after 15 is deleted, this is going to be your last node. And this last node, we have to update this 3000 to null, because if we are deleting this, there is nothing after this node. So this 3000 should be overwritten with the value null, and this should be freed. So okay, so we know how to get to this node from our previous loop. If you remember, I'll show you that once again. This was the loop that takes us to the last node. So if we write this loop, we will be at this node. But to delete at the end, we have to be in one node before the node that we have to delete. So this loop will work, but we'll have to modify a little bit. So how do we modify? So this is the modified loop that we use for traversal. This helps us to have the value 3000 as well as the value 2000. And how do we have it? Let me put all of this in the picture. Okay. So you start with 1000. 1000 to next is 2000, which is not null, so you'll go inside. You copy 1000 in temp 1 and 1000 changes to 2000 here. So now you have two variables, one has 1000 and one has 2000. You go back here, okay, and now temp is 2000, so 2000 to next is 3000, okay. So it's still not null, you'll enter again. Now 2000 gets overwritten on temp 1, which had initially 1000, so 2000 and this becomes 3000, okay. So if you see, this is 2000 and this is 3000. You should always refer to this figure when you are doing this traversal. So now temp 1 has 2000 and temp itself has 3000. So when you go back to the loop, 3000 to next is null, so you will come out of the loop. So now your temp has 3000 when you come out of the loop, and your temp 1 has 2000. So we have tried to retain the previous value of temp within the loop, so that when we come out of the loop, we have temp 1 pointing here and we have temp pointing here. So to delete this, we will be using temp 1 instead of temp. So how do we go about that? So this is the value that I have now. Temp 1 has 2000 and temp has 3000. 3000 to next is equal to null, so you will exit the loop at this moment. And now this is what we have. Okay. So temp 1 is here. This is your temp. This is what we are going to delete. Okay. So we have to delete this. Delete means we can just say free temp, because this is not linked to anything ahead, so we don't have to worry about saving this temp value for using further. We still have this temp value here. Temp is 3000 and 3000 is here. So once we say free this, so this node is returned back to memory, and now all we have to do is to update the next field of temp 1 to null. So I'll just write temp 1 to next equal to null, and this is how I get done with deletion at the end. Okay, so I hope this is clear. So I'll be sending you all these notes. I'll take clear pictures of each node, and then you can follow them up once you are watching these videos. Okay. So the next topic we're doing is addition and deletion at a particular position, not in the beginning, not in the end, at a particular position. So I guess it will take some time, so I'll do it in a separate clip. So your lecture number 5 will be add delete at a particular position.